A projectile is an object that is in free fall and moves horizontally at the same time. Things like footballs, soccer balls, or bullets are all examples of projectiles. A dropped object will fall straight down towards the ground. The only force acting on it is gravity, so it is in free fall and accelerating at 9.8 meters per second squared. That means the speed of the object increases 9.8 meters per second every second that it falls. Therefore, it covers more and more distance each second. A thrown object takes a curved path towards the ground. It is moving horizontally forward while also moving vertically downward at the same time. The ball is in free fall, so it accelerates downward at 9.8 meters per second squared, just like an object that is dropped straight to the ground. If the object is thrown faster, it will still take a curved path, but will travel much farther before reaching the ground. It will have more horizontal velocity, but is still in free fall and accelerating downward at 9.8 meters per second squared. If the object is thrown really hard, it will travel really far on a curved path towards the ground. The object has a lot of horizontal velocity, but is still in free fall, accelerating downward at 9.8 meters per second squared. If the object is thrown on an upward angle, it still takes a curved path. On the way up, gravity slows it down, but it's also still moving forward. At the highest point, it continues to move forward but stops rising. Then, gravity speeds it up on the way down. It's in free fall, accelerating at 9.8 meters per second squared. Here's an object dropped straight to the ground. Here's an object thrown off the table. An object dropped straight down and an object thrown horizontally are both in free fall and land at the same time because both accelerate downwards at 9.8 meters per second squared, while the thrown object is also moving forward. Here are two projectile motion simulations. In the first simulation, the biker becomes a projectile once it leaves the ramp. The path through the air is a curve. The bike provides a horizontal force which gives the bike its horizontal speed, which stays constant once the bike leaves the ramp. Well, ignoring the fluid friction as the biker moves through the air. Vertically, however, the bike accelerates downward at 9.8 meters per second squared, once again ignoring the effects of air resistance. The velocity of the bike decreases as it rises and then increases as it falls towards the ground. There are two variables that can be manipulated. First is the angle. Different angles will result in the biker traveling different horizontal distances. The second variable is the initial velocity. The speed that the bike travels off of the ramp will result in the biker traveling different horizontal distances. Second simulation, the archer is trying to shoot the coconut with an arrow. The arrow becomes a projectile once it leaves the bow. That means, once it leaves the bow, the only force acting on it is gravity, so it accelerates downward at 9.8 meters per second squared while also moving horizontally. If the coconut is dropped so it freely falls to the ground, then it will accelerate straight down at 9.8 meters per second squared and will not move horizontally. If the archer aims directly at the coconut and fires right when the monkey drops the coconut, they will both accelerate downwards at the same rate, 9.8 meters per second squared, and the arrow will hit the coconut. The velocity of the arrow can be thought of as having two parts, vertical and horizontal. The vertical part is the same for both the arrow and the coconut. However, horizontally, the arrow is moving forward while the coconut is not. The same thing happens if the archer has to shoot upwards or downwards at the coconut. It will still accelerate at 9.8 meters per second squared.